This is what we call severe damage. This is the bridge out of town, and we're not going anywhere.
A woman was stranded here all day long through the storm.
Oh my God!
Tropical Storm Irene bears down on New England. In Vermont, the storm pushes up against the higher terrain, and the rain intensifies. This is the worst flooding Vermont has seen in nearly 75 years. Tropical cyclones, a general term for hurricanes, typhoons, and tropical storms like Irene, don't just stick to the tropics. These storms can charge northward and wreak havoc in areas that normally wouldn't see this kind of extreme weather. Satellites provide us with near real-time information about the intensity of storms and where they're headed. Since its launch in 1997, TRMM, the Tropical Rainfall Measuring Mission, has remained a gold standard in collecting global rainfall data on storms.
TRMM's usage for hurricanes has also been a major application. Operational agencies use it to get center fixes on storms, to monitor how the internal structure of a storm is changing and how that might relate to the potential for a storm to either intensify or weaken.
And while TRMM provides essential information on cyclones for tropical areas, for regions like New England, TRMM simply falls short.
We knew going into TRMM that there were going to be some limitations, the primary one being its relatively low sensitivity so that it would not be able to get the fairly low rainfall rates that you might see up at higher latitudes.
So part of what GPM was supposed to do was just continue those measurements. But also GPM is to improve those measurements by being able to, for example, measure precipitation over a wider swath of the Earth. TRMM is just at about 35 degrees. GPM gets more of the Earth in its measurements, going all the way into southern Canada, for example.
The Global Precipitation Measurement Mission, or GPM, is a constellation of satellites unified by the GPM core spacecraft that will provide a global picture of rain and snow every 3 hours. When GPM launches in 2014, it will greatly improve upon some of the limitations of TRMM. In addition to measuring a wider swath of the globe, the GPM core spacecraft will carry more advanced instruments with greater sensitivity. There's the GPM Microwave Imager, or the GMI, a radiometer that will use 13 microwave channels to capture precipitation intensities and horizontal patterns. Then there's the Dual Frequency Precipitation Radar, or the DPR. That uses 2 frequencies to visualize in 3D the precipitation structure from the cloud down to the surface.
With GPM, we have the opportunity now with more advanced technologies to improve upon TRMM by having that second frequency and being able to measure the lighter rainfall and produce a more accurate rainfall estimate by having the two combined.
With GPM's more sensitive instruments and wider coverage of the globe, we can more accurately profile a tropical cyclone, predicting where they're likely to form, how intense they're likely to become, and tracking the path they'll take so that agencies can make better decisions to help get people out of harm's way.